I'm Miss Schaefer, and today we are going to talk about the Cranmer Abacus. Now, what you see right here are two styles of Cranmer that we made ourselves in class. To make one yourself, you need some hot melt glue, 5 popsicle sticks, 3 pipe cleaners, and at least 6 sets of 5 beads. You can make it easier and just do a couple of lines if you're just going to make simple numbers, but I liked this because it's going to allow us to go up into hundreds of thousands. The nice thing about any abacus is that it is a simple way of teaching or learning place value. It can also help you do addition and subtraction in a hands-on way without just counting on your fingers and maybe toes. As we go across, I'm going to talk about place value. Right here, before we do that, I'm just going to talk to you about the colors. In this case, we chose one with alternating colors. Usually you will see Cranmers or Japanese style abacuses with just one color all the way across, and you just remember that as you go across, your place values are the ones line, the tens line, the hundreds line, the thousands line, the 10,000s line, and the 100,000s line. So 1, 10, 100, 1,000, 10,000, and 100,000. Although usually when you're working on grade school level math, this middle would become a decimal. I'm going to show that over here. If the middle is our decimal place, then this line right here becomes our tenths. This point becomes our hundredths place. This point becomes our thousandths place. And then on the other side of the decimal, we have our ones, tens, and hundreds. So that's 2 different ways to use a Cranmer as far as whether or not you want to use whole values or decimal values. You can notice the colors on here that we chose. On this one, we chose colors that alternated just so that we could tell when we were moving from one place value to the next place value. Here, since each movement is an order of 10, I chose different colors to represent that so that I know when I'm moving my ones, I'm moving red. When I'm moving my tens, I'm moving purple, and so on across the way. We're going to talk a little bit about different ways to represent the same thing as you do on an abacus. Like, as I move everything off the screen, we're going to erase these place values and just trust a little bit. And I'm going to use my colored abacus for demonstration purposes. Now, since this is the ones row, everything down here has a single unit. So this is 1. It would be the same if we were using pennies, as a penny in value as 1 cent. Or if you're using manipulatives, it would be the value of 1 army man. If we were using dice, we're just going to have a 1 on our die. So these are 3 different ways that that number is represented on an object. If we were to go 2, so 2 little beads on the right-hand strand, since those are our ones, we know we would go up by a cent. We would go up by another army man. And we could go up by, we got some tokens over here. So we have 1 and 1, making a total of 2 tokens, or we could roll our die over to a value of 2. Since these are numbers, that's a more abstract way of representing the same thing we've done in a concrete fashion with all these other manipulatives. It gets more interesting when you go up to the count or value of 5. So with 5, we're looking at our little Cranmer, and we see that we can go 1, 2, 3, 4. But when we get to 4, we have to go up here. Each one of these beads is a multiplier of 5. So my 1 bead down means all these need to go away, and that single bead means a value of 5. So if I'm going to represent that with my other manipulatives, I need 5 pennies or 1 nickel, since those are the same way of representing a quantity that's higher than just one piece. With my tokens, since there can only be ones, I'm really just going to have to put 5 tokens. With my dice, I can just roll that over, or my die, to be a 5. But with my army men, I either need to level up and say I get 1 orc is equal to 5 army men, or I need to say that I got 5 little guys. So what happens when I go 6? When I want to count up to 6, I keep my 5, and then I move up another 1. This gives me 5 plus 1, which is 6. So I'm going to represent that in different ways. There's my 6. My pennies, or nickels, would be a penny and a nickel. My 1s, which are still going because I have not achieved the value of 10, which is their next unit. And I can just count that that's 6 or 1, 1, 1, 1, 1, 1. And with my army men, we're going to have to send out some recruits. I have 6 guys. Now the nice thing about using representative units is that I only needed 2 beads to represent 6. I only needed 1 die. I needed 2 coins, but I needed 6 individual items for things that are all valued at 1. Just like I needed 6 individual tokens to equal the value of 1. The same thing goes with going up to 7. 1 little slide of the bead, and I have 5 plus 2, which I know is 7. So with my coins, I know my nearest unit is 1. So I'm going to bring over another penny. With my die, since it goes up to 10, I just roll it over to 7. Over here with my tokens, I get a value of 1. That's a lot to keep track of, and almost every time I have to think about it, I have to count them individually, unless we group them by 2s or something like that, to say that I can skip count 2, 4, 6, 7. And my little guys are just getting more and more rambunctious over here. They're not a very organized platoon at all. So they need another guy randomly stuffed in there. If we don't organize them into a powder, this is what 7 looks like to us. We need to organize them into groupings to keep track of what we're really doing. The beads on an abacus help us do that organization in 5s, plus our additional units. So here we go. We're going to go clear up to 9. Here I have my 5, 6, 7, 8, 9. So all my beads are together and close to the bar. If I roll my dice over, my die, I'm going to use the one with the line on the bottom because that's how we tell it's a 9. That line means the bottom. My poor little singles over here, I'm going to have to keep going. So there's my 8. And 1 more gives me 9. And my little army men. I know that 3 and 3 is 6. 7, 8, and 9. Blah. Sometimes when we start counting, we have to think in concrete terms like these little army men or these little single die or single items over here. But after a while, it gets hard. Once we get 20 guys, if we have to count those 20 guys every single time, it's just going to be a mess for us. We're going to lose track of it. So using something like the abacus helps us keep an order to it, but still we're working in a concrete way. So let's talk about 10. We know that this line here was our ones. This line next to it is our 10. We can think about that as a power of 10. If we're that advanced, because we can say our ones are really 10 to the 0 power. And our 10s are really 10 to the first power. But most people who are watching this video aren't going to know what that is yet. It's just sort of a preview of things to come. We know that all these beads added up to 9 for us, but since we're going up to the next level, we're going to slide those back to their home positions, and we're going to bring up 1 bead because it has the value of 10. So representing that as money, we only need 1 bead here, and we do the same exact thing with money. We only need a dime to represent that 1 bead because it's in the tens column. This has a value of 10. Our army men have already surpassed their usefulness. Well, let's throw another army man on the stack. There's our 10 army men. A magical thing happens, our army men. Over here we have a magical moment where our 9 little tokens can be replaced by a 10, but we're not going to get rid of them completely because we know when we start again, we're going to have to bring in the tokens clear up to the value of 10. With our die, because it's a 10-sided die, we can just go up to 10. So just like the dime, those two are going to have the same value. When we want to start counting with our 10, like 11, we're going to go back to the ones column and start counting up the same way that we would with our dime. We would add a penny to give us 11 cents. Our army men, we would throw another guy on the pile. And with our tokens, we would bring in a 1. We're going to have to, if we keep going up with our tokens, we're going to have to add 9 tokens before we can go up to 20. Over here, we don't have that kind of luxury. If we want to go clear up to 20, we're going to go our 10. And then we actually know from experience that 2 10s is 20. If we were adding 10 plus 10, we would want to think about it like this. I have 10 plus 1 is 11, 12, 13, 14. Then I know I come up here and bring down my 5 for 15 and send all these home. If they will work for me. So 15, 16, 17, 18, 19. So I've used everybody up. I have to go back over here to get my next one and send all my ones home. So in this group, if I had 20 army men and I didn't want my troops to be crazy like this, I might upgrade to, say, a general that I have decided is equal to 10 army men. And then another general, which is equal to the other 10 army men. Let's use this big guy as our other general. That helps us skip count as well, because we can say 10, 20 without having all this pile of little guys making chaos for us. In our tokens, it's lucky because we can just put another token down. And for our money, we just put another 10 down. With our die, since we reached the maximum at 10, we would have to add another die with the value of 10. So let's start looking at some bigger values. If I want to go to the hundreds, all of a sudden I'm looking at a whole different situation. I know my change only goes up to the quantity of 25. So I can look at it in different ways. I can move one bead in the hundreds column, and that gives me 100. I can use one 100 token. I could have 10 tokens, and that's a lot of tokens, so my patience with that is probably going to wear thin, as well as space, so let's discard that. With my quarters, to equal that, I'm going to need 4 of them because they are only a quarter of a dollar. I like how the name works out like that. For my dice here, since I am using them as 10 and I'm going to 100, I would need 8 more die with a value of 10. That's basically 80 plus the original 20 that we had. And that's a lot of die or dice because I often go back and forth on that, even though I shouldn't. Okay, so you get the idea here. What I've decided, though, is to save myself some effort. I'm going to use my die as place values. So if my purple is 1, I know that I have a 0. And my orange or red is 10, I'm going to leave it at 0. But here, since this is my hundreds, and I'm trying to get to 100, I'm going to roll that over. So we have used place value the same way that we're using place value over here. This is equivalent to 0. This is equivalent to 0. This is equivalent to 100. We're not even going to talk army men. Because since each one of these is worth 10, we know we would have to have 10 of them. Okay, so let's talk one more thing, and that's going to be addition. When you start using this for addition, it gives us a little bit of flexibility because we can say, I have 5, and I want to add 6. So I know the first thing I'm going to do is represent my first number by bringing my 5 up. The next thing I'm going to do is add 6. So I go 5, not counting from the 5, just go 1, 2, 3, 4. I've reached 5, so I'm going to have to go up here and bring over a 10 because 5 plus 5 is 10. And then I go 1 more, and that gives me 11. 10 plus 1 being 11. With my tokens, I would have my 5, which I don't have. I have to have a stack of 5. And then I would have to have a quantity of 6 because we don't have anything to represent 5s. There's 4, 5, and 6. And then we would use grouping to figure out what we could replace those with. So we would say, okay, our next thing up is 10, so I would have to group my 1s in groups of 5. And then I would say, okay, all these together equals my 10. I'm going to take those away and put my 10 in there and add 1 to it so that I have 11. With coins, it was a little easier. I know I have a 5 here and a 5 concealed in that 6. So I would have my 2 nickels, 1 for each of the 5s. And then I would add a penny because I know 5 plus 1 equals my 6, and then I have my 5. And then I would go, hey, 5 plus 5 happens to equal 10, and I happen to have a coin that represents this amount. So I would replace my 2 5s with a 10-cent piece. All these things become representative of what we have on the abacus, but we didn't have to have individual items to do it. Let's add 100 plus 2. And then we're going to call it a day. So, put everything back. Making sure that your beads are in the right position is going to be the best way to make sure that you have what you need and that you're reading your number right. So if we're doing 102, you can see right away that we're going to have a bead in the 100s place. I'm not going to have any beads in my 10s place, but I'm going to have 2 beads in my 1 spot because that's the value. So there's 100 and 2 ones, which is what I've got. In token land, I know that I happen to have a 100 token, but I don't have anything worth 2, so I would just have 2 ones. With money, we already discussed the fact that 4 quarters equals 100 pennies. But for us, in our money system, we also know that a dollar will replace those 4 quarters, which lightens things a lot in our pockets. One thing that we also have are manipulatives that show the size of things. So with those, I mean, we've looked at the different ways. Like this just has a 100 printed on it. This has all the values of each bill, even though it's still a single bill. If we had a one $100 bill, it would still be worth 100 ones, but we just give it a value. When you use things like this big block is 10 by 10, which is the value of 100. If we break it down into stacks of 10, we would have 10 of these stacks right here. If we want to represent our number 102, we would have to have this big chunk plus 2 little chunks. I don't know about you, but that doesn't seem very practical to carry around in your pocket. So I'm really glad we have a representational money system. But the sooner that we can learn a kind of symbolic way through place value to get what we want, the easier it's going to be to manipulate. And the Cranmer is a great way to do that. Thanks for your patience and watching along, and I'll see you next time.